Hi. Thanks. I'm going to talk about automating web performance optimization. Yesterday, we already heard a talk about why web performance optimization is important, and you had the chance to hear the basics about it. But since this is a DevOps conf, I'm thinking automation is something we should all strive to achieve. What I'm going to do is I'm going to tell you a story of success and failure in a company I was working for, and how we could have prevented the failure part if we had automated things. There is a lot of information on the slides. There are few slides, but there's lots of info on it. There are links to hopefully everything. So if you want to check things out while I'm talking, I created a short URL to the slides on SpeakerDeck, so you can check them out on your devices while I'm presenting in case you can't read anything on the beamer. Okay. So, a couple of years back, in a company far, far away, I started working there, and it was a umbrella association for internet businesses and accidentally also the largest peering exchange in the world. And they ran a couple of sites, so like 40 plus websites. When I began working there, I saw that statistics for most of the major sites they were running, especially the one major site for the umbrella association itself, had dropping stats across the board. So they had dropping interactions from users, dropping newsletter subscriptions, people didn't respond to press releases anymore, all that kind of stuff. And it wasn't like it was a sudden drop or something, like we did something awful or something technical went bad, but it was a linear drop. So you could basically see that in the past there had been a certain audience that was interacting with the site, but step by step they became discouraged to do so. They didn't like the content anymore or how the site worked, and so they gradually moved away. That was what I saw when I opened the statistic tools for the first time. So another thing is that I saw that was really, really curious was we had traffic spikes like this. So this is the normal traffic, and this is like, woohoo! There's something going on here. What's happened? That's happening when there's a big news release or the company released a new product and there was big press coverage about it. So the additional problem I faced when working there with my team was that we had to deal with traffic spikes like this. Not only had we had to improve the platform, but the platform also had to cope with things like this. So this is the outset. And then we asked ourselves, okay, what is causing this drop-off in interaction with the sites? And I wrote you the matrix quote, obviously, as we're all nerds. Causality. It is the one constant. It is the only real truth. You remember the Merovingian from the Matrix? So we took his line and we thought, okay, let's find out what's the cause. What causes this? We had the basic analytics tools I already showed you the graph of, but we didn't have much more to go on. So we implemented measurements and we did user interaction interviews, screenings, all that stuff. We used two tools that some of you will probably have heard of already. One was mentioned yesterday, I think. This one is called Web Page Test. Web Page Test is created by someone at Google, Pat Neiman, who does awesome work. And Pat Neiman has released this time and time again, and now it's a huge network of servers you can contact to test the performance of your site. You can just go to a location that is near to the location your customers are in and test your site. There is also the open source version you can host yourself, or you can request an API key to use the network that's already established. So that's one of the things we use to try to understand how are the sites we are trying to improve performing, and do we need to improve them, and if yes, where? And another thing that's really important is we didn't only use web page test, but also another tool. And why did we use two tools? Because there's two types of testing. There is synthetic testing, which means you test from a location that's hosted in a data center, which isn't always the way people interact with your site. You know, it's a big server, it has a good connection. So the statistics you gain from synthetic testing aren't accurate enough. So there is another way to measure things, and that's called RUM. You know, Captain Jack Sparrow, where's the RUM? Why is the RUM always gone? RUM means real user monitoring. So what you're doing there is you're using JavaScript to basically report statistics from real users who interact with your site, post it to a beacon server, and log statistics. So you get actual data. There are cool developments on this. There's the navigation timing API developed by W3C, which gives you basic statistics. And right now they're working hard to release the resource API, the resource navigation API, I think. Well, which basically gives you proper statistics on every asset you load in a website. JavaScript, CSS, every image. So that would give us huge amounts of data to work with and have real user data. So we use these two tools to find out where are we standing right now. And what I brought you here is a graph I've created over the last couple of months. This is data that CDN providers and parts of the Alexa Top 2000 released themselves about bounces and abandonments correlated to load time. Percent, load time in seconds, and bounces and abandonments. Abandonments means that somebody actually leaves your site, and for the sake of this statistic, it also means they don't return in 6 weeks' time. So that's not just abandonment 1, but that's abandonment and I won't come again because I'm pissed with your site. So you know, this is really an important metric. So this graph is normalized above the Alexa Top 2000. So this is quite valid data. And when we measured all these things, we found out we were about here. So that's quite bad, right? 6 point something seconds. And that explains a lot why we saw dropping interactions. Because we had a bounce rate that was like 62, 65%. That's not too bad, but it's also not good. And but because of the bad load time, we had lots of abandonments. People didn't really want to wait for the site to load, so they left. Or if they were actually hooked from a press release, they maybe viewed one more site, but you didn't really manage to get them to subscribe to a newsletter or go to the events site to find out, oh, there's an event happening soon. That's nice for the business I'm in, so let's go there. All these conversion goals we had for the sites, they didn't really pull through because of the very, very bad load time. So the first thing we did was we were charged with creating a proper new stack that could handle all these traffic spikes and could handle the users and performed nicely. Brian McAllister yesterday already said that there is a time in each company where you want to get more control over your infrastructure and you want to gather more statistics. You just don't want to go with hosted services anymore and don't know what's going on there. There is a time where you want to get control over everything. It's kind of control freakish, true, but still that's the way it goes. So we went away from managed servers and managed hosting and created a proper high-performance stack. In the talk about charity infrastructure yesterday, there was a lot of talk about Varnish already. Varnish is a really, really cool piece of software, which what it does basically is if user traffic comes to your site, it fetches information from the backend, caches it statically, and delivers it to the users, and primes its cache. So the next time a request comes in, this thing will answer, and the whole backend infrastructure won't even be bothered with it. So it caches properly. That's really cool. The next thing we used is Nginx, obviously. It's the new kid on the block concerning proper server infrastructure. I loved Nginx because of its syntax. It's really nice. Also, Nginx performs much better serving static resources than the old Apache does. And because we were running WordPress sites, because all the editors, all the content people were already trained in using WordPress, we were kind of forced to go with PHP. So we didn't use a classic PHP thingy. We used the FPM wrapper for PHP, which basically creates a cluster of processes that can handle the PHP requests and can scale quite nicely. And because WordPress isn't that complicated under the hood, I mean, it's dirty, but it's not complicated. We used an opcode cache to create binary state data from the processed PHP. So each time there is a request that doesn't hit the varnish cache, the PHP is already pre-processed, hopefully, and gets delivered without PHP actually doing any kind of calculation. And if the request actually hit through, there is MySQL with the whole caching thingy in the back end. But what we saw is, with a stack like this, MySQL doesn't get bothered much anymore. That's really nice. And also PHP doesn't get bothered much. We had a dynamic tool to increase the size of the PHP cluster. And what we saw is most of the time the cluster ran in its minimal configuration because there was no need for more PHP processes, because like 85% of all the traffic was handled by Varnish or then Nginx with static files. So that was really nice. Because we created this thing to be deployed on all the sites later on, we managed to create this VM we could roll out for each new site, or to relaunch the sites we were already running. So we could clone them, the clone wars. We could clone this stack and deploy a new site or port content from an old WordPress or an old other CMS into WordPress, and then we could handle these kind of traffic spikes, we thought. But like Steve Souders always says, web performance isn't really back-end anymore. Web performance is 80% front-end. Actually, I think in a blog post like one or 2 months ago, he even said that it's more nowadays. So no matter how great you scale your stack, no matter how good it is, no matter how much it performs, if your front-end is really messed up, it doesn't matter. If your front-end is cluttered and you have lots and lots of HTTP requests going in there, the stack doesn't really manage to make your site load in a second or two. So we had to consider front-end, of course. And with front-end, I mean all the stuff that makes up a site. Images, videos, JavaScripts, and JavaScripts that load JavaScripts, and funny stuff like that, and CSS, Flash, and there's something of note, measurement tools. Most people forget this, but if you include lots and lots and lots of monitoring and measurement tools in your front end, it actually manages to slow down your site. It's a funny thing you should watch out for. Just check that whatever it is you use to monitor doesn't mess up your stats in itself. So we had to learn how to optimize the front end. And to do that, we tried to discover what are the things that make a website slow. And actually, nowadays, the best place you can go to find this out is Steve Souders' HTTP archive, because he tracks more than 1 million sites now, I think. And what he does is he aggregates all the data of how many images are there in a site, how many Flash objects, how many JavaScripts, which kind of JavaScripts, does the server use proper caching, etc., etc., etc. So that's the kind of thing that the HTTP archive tracks each and every month, iteratively. You can also host HTTP archive yourself and track only your sites. It runs on with web page test in the backend. So if you're thinking about deploying web page test for synthetic testing for the sites you run, you're one step away from also using HTTP archive to have proper growth or non-growth stats for the assets in your site. So when you look at HTTP archive these days, the thing you see is that images have the highest correlation between page load time and their size. So if you have lots and lots of images in your site, that means it's the #1 thing you should think about optimizing to reduce load time. And then the next thing is obviously all the load time and then HTTP requests. So this is really, really important. Priority #1 is optimize images. You wouldn't believe how many websites, how many of the top 100 Alexa websites still get this wrong. They don't compress JPEGs right. They don't serve WebP if they could. They use PNG24 for photographs. They do awful stuff. So you should really, really think about compressing images. This is actually one of the things I'm going to talk about, how to automate this later. Image assets, important. This is a graph that shows you how much image assets have grown over this statistical database of more than 1 million sites in the last 12 months. So you have like 400K in 2012, and you have more than 600K in 2013. So that means images are getting bigger and bigger these days. This is of course also because of retina displays, and developers are trying to solve the whole retina display issue with photographs, but it's also because of a change in design. Most websites you see these days, if they launch a new product, they launch full width images to convey emotion. They have huge images at the top header. So this is also another explanation for why images are growing so rapidly on websites these days. I already gave a talk about how to optimize images in detail, and also how to automate these images. If you want to go into more detail, just check out the other slide deck. This is only concerning image optimization. So the next thing we did is obviously JavaScript and CSS, because that's really important concerning page size. jQuery is really huge, and other JavaScript libraries are really huge. And CSS is actually called the critical path these days, which means nothing is shown on your website when loading until the CSS is loaded. So if you have like 500 kilobytes of CSS because you loaded Twitter Bootstrap, Twitter Responsive Bootstrap, Normalized CSS, Eric Meyer's Reset CSS, etc., and then also your CSS, that means visitors will have to download X hundred kilobytes of CSS before anything is displayed on their site. So what you should really try is trim down CSS, like Snook already said yesterday, fix your CSS properly. We also profiled the CSS with performance profilers to find out if we had awful selectors. Snook talked about this yesterday. And for deployment, we wrote bash scripts that concatenated all the JavaScripts into one thing and all the CSS into one thing, and then minified them. And we had the server gzip the whole thing again. So we had one JavaScript file, one CSS file, and it's minified and gzipped. So that's the best you can do, I think. And of course, because we had this high-performance server stack, we thought about caching headers. That's also something lots and lots of sites get wrong these days, is how to cache things properly. They forget to set caching headers that make images cacheable in the browser, or they send things like revalidate by accident. You know, that means that every request the browser does, it has to recheck with the server. That's awful. Why do people do that? It's just because they forget. So take control of your stack if you can, if you dare, and implement proper caching headers so that when people come with an empty cache, they only have to load your entire website resources once. And then, after they have visited your site once, lots and lots and lots of stuff is already cached in their browser, and if they have returning visits or if they go down your conversion path, each other website within your site is loaded much more faster because it's only like 1 or 2 requests. So, after all this stuff, you would think we would have done great, right? I mean, it's a high-performance server stack. Everything is concatenated, minified, optimized, profiled, monitored, blah, 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 blah. So, what could possibly go wrong? So we launched. And we also had load testing to make sure that on the live side that even if people hit the site now with high traffic, it would still stay stable. And even the load tests say, yay, you're doing a great job. So we thought time to party. I mean, look at our load time was 1.3 seconds. That's like almost time to glass, what Ilya Grigorik is referring to these days as the optimal page load time. So we were really happy. But we messed things up. There's no time to party. What we forgot was how to prevent performance regressions. That means we launched an amazing website once. But a website is not a static thing. A website grows, especially sites that deal with news, that have multiple content editors. It's an evolving thing. It doesn't stay static. And unless you think about this, you will mess things up in the long run. So what we forgot is how to automate things and prevent how people could mess up the site. Things that go wrong over time are unoptimized images get uploaded. Like I said, we were running WordPress, and naively as we thought, yeah, WordPress is using GD in the background to optimize images. Yeah, screw that. Images that that are in the WordPress media library are not compressed. They're awful big. So we forgot to optimize the images that editors would upload later on. And I've been just working for a client who has the problem that they're uploading full-size images from stuff like Stock Exchange and all these high-resolution artsy photograph sites. And so they are delivering, if they don't pay attention, they are delivering 3,000 something by 2,000 something pixels to their customers every day. That's just what happens if you don't pay attention to optimization for images. And then what also happened is we got a new designer, and we tried to train the new designer, obviously, but what we forgot is how to tell him how to maintain a sprite we used in the site to reduce HTTP requests. So a couple of months later, when he was in charge of creating new icons, he didn't know better, so what he did is he implemented all the icons separately. So every single icon that looked exactly like all the other icons we had in the sprite was creating a separate HTTP request. So if we went from 11 or 12 HTTP requests up to 17 and then 23, which was awful just because of these little icons. It could have been prevented if we had automated sprite creation. I forgot one. And also, what I saw in a couple of clients' websites is they install plugins. People install plugins, especially in things like WordPress, where there's more than 1 million plugins, and everybody thinks getting new functionality in WordPress is easy by just installing a plugin. That happens a lot. But what they don't realize is that most of the plugins are awfully coded, really. I did code reviews for many WordPress plugins, and very many of them are awfully coded. And they have third-party requests, like they load jQuery no matter if you already have loaded jQuery. They just don't use the proper hooks that WordPress brings with it. So what they do is, I'm a slider plugin, so I need animation. So because they don't know any better, they don't use CSS animation, which we GPU accelerated. No, they use jQuery. And then they don't even check if you have already loaded jQuery. They just force you to reload jQuery. So that's what happens if you use plugins without thinking about it. So these are things that make you grow from slim and trim to that, fat and slow, over time. So what you can do to prevent this is step A, monitor things. Use web page test and use New Relic and whatever performance tool you love, and make sure that you monitor it properly, monitor your sites properly, and have alerts. With these alerts, basically make you aware of things that go wrong. That's also something that I saw a couple of times already. People have implemented monitoring, but they're not looking at it. You know, they have this thing like, oh yeah, Friday afternoon, if there's nothing to do, I will check out my statistics tool and my performance monitoring tool. But they don't have any alert system on it, so if things go wrong on Monday morning, they don't notice. So make sure that whatever tool you use to monitor, make sure that it can send alerts. One of the easiest thing to do is really just write a bash script that parses your log files and sends an email. That's so easy. I pushed one on GitHub that's like 40 lines of code. It's really simple. So there's actually no excuse for not losing alerts. And when you do track your performance data, make sure you correlate it with your conversion paths. So make sure that the conversion paths you have on your site, I'm not talking only about e-commerce, but a conversion path is things like you want people to download your software, you want people to subscribe to your newsletter, to click on your Twitter profile, or whatever. Conversion paths can be any interaction that you find desirable, that people would do with your website. Define these things, create conversion paths, and then make sure that you monitor each conversion path. And that each step within each conversion path actually is performing excellently. That's what you want. So I've talked about the things that are important for web performance, and like I said, the most important thing to think about is image optimization. So this is one of the things I want to tell you how to automate. And I want to show you something that's created by Google, which is called PageSpeed, or for Apache ModPageSpeed, which is a module to automate most of these things. So you don't have to care about it, and you don't have to do it manually. So let's look at image optimization first. Something I'm always advising my customers is Don't try to fix it all at once. It doesn't work. Go step by step. The first thing you do if you have more than one person maintaining the website is give all these people some sort of tool to compress images on their desktop. I know that's not automation yet, don't worry, I will come to that. But give them a chance to do better. So there is the most famous one, ImageOptim from Pornelsky, which is basically one of the best tools you can get for Mac OS X these days. There is Trimage for Linux, and there are also Windows ports of these tools. So they are basically small little programs people can start and drag and drop the image they want to upload onto, and it gets compressed on their desktop side. So you don't have, as a developer or as a server admin, you don't have to do anything about that. So that's really good. That's a good first step. But as we all know, people fail. You know, there's a stressful day and people need to push out their new article, their new blog post, whatever, so they forget about doing this. So the next thing you should think about is how to automate optimization on the server side. And one thing you can do, especially easily with WordPress, is you can hook up into the uploading process. So if somebody uses the CMS backend to push out a new article, to push out new content, they have to upload the images, right? They have to put them somewhere. They can't just use them from their desktop, so they have to upload them. You can just hook into that process and take the images that get created server-side and optimize them. For WordPress, for example, there is a nice hook that enables you to fetch each image as it gets created in different sizes. WordPress creates different sizes for each image, and then run them through an optimizer you have installed server-side. Things could be JPEG Optim, JPEG Tran. I've created a new tool that's called Adapt, which basically does adaptive image compression. Link is also on that slide. And you can install these tools server-side and then use a plugin to make use of these tools and compress images as they come in. And then the next big step, that's actually a huge one, is go away from hosting the images yourselves and find a hosting provider, a CDN provider who does image optimization. There's lots of them out there now, since the cloud has become such a big thing. So it's really good to find a hosting provider who gives you the ability to compress images for you. Thing is, you will have to change your upload process, right? You will have to write some sort of code that enables your CMS to understand, okay, images are not going on my server anymore, images are going to the CDN server. So you will have to fix that. But that's actually a good multi-step of advice. Enable your editors and then enable your own server, and then in the next step, make sure you serve images from a CDN. To give you an idea of how much you could save, this is a testing image I've been using for Adapt. This is the original I found. I think it's 1024 by 640, and the original is 650K. It's huge, right? For a picture of that size, you could probably get a picture 4 times that size with this byte size if you optimized it properly. So if you use standard tools that are available on every Linux system these days, it's like JPEG Optim, JPEG Rescan, you can compress this into 110K. JPEG Optim is a lossy compression tool, so it loses quality. And JPEG Rescan is a lossless compression tool, but it strips all the EXIF data and stuff like that, so it's really good to run both things. What Adapt does, you can find Adapt on GitHub, is it scans the image for patterns with high contrast areas, like, for example, this line here, and then compresses things that don't have any high contrast areas more strongly than these ones. Because maybe if you have seen JPEG compression in the past, you will notice that areas with high contrast get these artifacts when JPEG gets compressed. That's awful. People always complain about this. Why does my image look shitty now? Because you compressed it. So what you want to do is you want to use Adapt and make sure that the images get compressed in areas which are suitable for compression and not so highly compressed in areas which are not suitable for compression. And as you can see, Adapt has some success there. So that's image optimization. And the thing I brought you today is, the next thing I brought you today is ModPageSpeed. And ModPageSpeed is a module created by Google, which is also now available as Nginx PageSpeed. And what it does is all these best practices we've been hearing from me and from the Akamai guy and from everybody here around who cares about performance, it tries to automate these things for you. So you can basically use a Apache server for ModPageSpeed or Nginx compiled with Nginx PageSpeed to get all these things for free. What it does is it hooks into the request coming in, and then it looks up if it already has optimized the resource or not. If it doesn't, if it fetches it from the backend, optimizes it, puts it into the cache, and then delivers it. So the next time the request comes in, it's already optimized, and it works quite nicely. Well, this might seem like black magic. I wanted to show you that it actually works. Some of the people yesterday didn't say they don't know what HAR files are or what waterfall diagrams are. I hope that you can do better. In case you don't, I put up a link there, also a short URL, learn about HAR, which gives you all the information you need to know or to understand waterfall diagrams. And what I brought you here are two waterfall diagrams from a virtual machine. One running a classic LAMP stack of Apache, Debian, Wheezy, and ModPHP, and MySQL, and nothing else. And then a clone of that virtual machine, but with ModPageSpeed enabled and properly configured. And you can see, if you can't see these things properly now, there are two short URLs where you can see this thing on your own device right now. The one thing you see here is this blue line shows you that the onload event of the page fires in 5.4 seconds unoptimized LAMP stack. Oh, by the way, the whole thing is a up-to-date WordPress, and what I used for content is a plugin that basically just creates random content. Then I disabled the plugin, obviously. And then I uploaded a couple of unoptimized pictures, and the worst thing I did is I included social plugins. You know, social plugins are really, really bad, because they load all these third-party requests. So social plugins are like the worst thing you can install in a CMS. So I installed them to give you an idea of a real site, because real sites do this. They upload unoptimized images, they have social plugins. So when I saw this waterfall diagram later, I thought, yeah, that's kind of what I've been seeing at customer sites. So that's kind of real. Okay, and then I tested this. Like I said, onload event for the unoptimized site, 5.4 seconds. The page complete event is somewhere all around 11 seconds, so not even on that screenshot anymore. And this is the exact same virtual machine, same stats, same everything, cloned, but then just enabled ModPageSpeed and configured ModPageSpeed, which is easy to do because it's really just a module. You can hook up your conf file and just say, yes, I want to concatenate JavaScript, yes, I want to optimize images, yes, 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 and then it does everything. And now look at that. LAMP and ModPageSpeed, onload event on 1.3 seconds. Woohoo! The site isn't rendered yet, obviously. For example, this content slider here wouldn't work on 1.3 seconds, but who cares, right? I mean, the site is rendered and people can interact with it.
Did you measure the impact on performance?
No, I did not, but because ModPageSpeed uses a real cache, you would have the CPU impact only once. So yes, you would have a CPU impact on the first request, but then after that, not anymore. So I don't think that's a big issue. Another big issue would be RAM usage, obviously, but I didn't measure that. You can do it. Wait for the next slide. So as you can see, some of the waterfall diagrams are shorter because ModPageSpeed concatenated JavaScript and CSS, and it loaded the JavaScript asynchronously. So the onload event is like here. And at least here, the page complete event is even on the slide because it's in like 7-point-something seconds or 6-point-something seconds, which isn't that good. But consider that the page has already begun rendering at 1.3 seconds, which is a big improvement concerning the other LAMP stack. So this guy already had a good question. And if you wanna test this yourself, and if you don't believe me, I brought you something. And what I brought you is the virtual machine image itself. There is a short URL again. Where you can download the virtual machine. So just open these slides in your browser, go to the link, click it, and download the virtual machine. It's a VirtualBox image that runs on every VirtualBox install. You can easily include it in your VirtualBox install and run it. The only thing you would have to do before you can run it is go to your global VirtualBox settings and make sure you set the network settings like I posted in this screenshot. You can see it better on your own device, I promise. And then I gave you information on how to log in and the users and where to gather statistics. People who already know Varnish know that there is a Varnish stat which you can call to see how many requests are hit in the Varnish cache, etc., how much RAM it uses, blah, blah, blah. ModPageSpeed has the exact same thing if you enable it, and I did. And that's situated if you start the virtual machine at ModPageSpeed statistics, and you can see all the things that ModPageSpeed has done these days and how much RAM it uses, etc., etc., etc. So what I want to enable you with is test this thing yourself. You know, if you are already running a WordPress site, export your content, start up your virtual machine, import your content, and have a play with ModPageSpeed. It's really a nice thing to do. And the great thing why you should do this is ModPageSpeed isn't a thing you should run all by itself, but you can integrate it into a stack. And that's what I've been experimenting with. I've been experimenting with including ModPageSpeed into this high-performance stack I've been showing you. One of the easiest things you can do is just use a normal Apache and have it run ModPHP or PHP FPM if you prefer. Install the ModPageSpeed Debian thing that is really easy. Make the Apache serve static files and have a MySQL thing at the backend. That's the basic LAMP stack, you know, the basic LAMP stack, but enabled with ModPageSpeed. This is basically the virtual machine I just showed you. But if you want to play with it and integrate it into a server stack that could actually serve hundreds of thousands of customers, you should think about integrating it into a bigger picture because this thing doesn't scale well. One of those things you can do is basically not install ModPageSpeed but Nginx PageSpeed, because then you wouldn't have to use any Apache at all, and Apache still has an awful RAM footprint, memory footprint. So you can recompile Nginx from source and compile Nginx PageSpeed into it, and then use Nginx. Or even for the adventurous amongst you, there is a Nginx fork called Tenjin by Chinese people. And what they enabled Nginx to do is include modules. So you don't have to recompile Nginx from source, but just go to GitHub, I think, and search for Tenjin, like engine but with a T, Tenjin. And you can hook up Nginx to use modules. Thing is, my advice is don't do it, because Nginx was created to be really, really fast and really, really small on memory footprint. If you force something that's not built for something to do something else, and that's what Tenjin does, it probably gets messed up. So I wouldn't use a module loader for Nginx. I would recompile from source. But then again, that's just me. Then another thing you could do is run this whole Apache ModPageSpeed thingy in front of the stack you already saw. What it would do is basically look up if it already compressed something, and if it didn't, cache it itself. But what the nice thing about this setup would be is it requests the thing from the Varnish cache that also caches everything. So the request from the Apache to Varnish would be really fast. That would basically cover more than 90% of all your traffic. So that's a nice idea. Or that's kind of hard. You would have to install the latest releases, the Debian, the beta releases of ModPageSpeed and everything. You can put Varnish in front of, say, Nginx to serve static files, and then have ModPageSpeed running on an Apache behind that, and then use either ModPHP or PHP FPM with APC, etc., etc. The way you should install the beta release is the ModPageSpeed developers messed something up. What they did is they forgot to not strip last modified headers. So Varnish had no idea if something in the backend changed and was serving stale content, means old content that's not valid anymore. So they fixed that in March, I think. So you would definitely need to install the beta channel to make sure that Varnish gets an idea if the content that's on the web server is still up to date or no. Okay? So if you want to find out more about ModPageSpeed, go to the Google developer site and speed ModPageSpeed to find these things out. Yeah, and that's it. Download the VM, have a play with it yourself, go to GitHub and look at the image optimization tools, because image optimization has the highest return on investment if you optimize them. And if you want to talk about these things some more, there's my Twitter handle. my email, website, etc., etc. And I'm going to be here until tomorrow, so you have lots of time to talk to me about that. Thank you.
Any questions?
Does PageSpeed automate sprite creation?
Nope.
Okay. Are you aware that there are solutions, at least
Yes.
for Java, that automate that?
Yes.
Okay. How do you find them? Because my recent research shows that they are really immature
Yep.
right now, and there's nothing really.
It's my opinion about that as well. Don't automate sprites. Don't
Okay.
automate sprite creation, but go with web fonts. There was a blog article this morning about how to automate web font creation on the fly. So you could basically just edit SVG, and SVG is using, there's a Ruby wrapper, and what it does is just look at if the SVG has changed, and if it has changed, push out an updated icon font with it, and set the proper glyphs. So I think automating icon font creation is better than automating sprite creation.
Okay. And have you looked into predictive spriting? That you are measuring the patterns in which the users are interacting with your site, and then you create sprites based on these patterns. So you are actually predicting what images will come to the in the next interactions with the site.
Ah, okay, nice.
So that's what our recent research is about.
Sounds good.
Okay.
I think this makes sense if your sprite gets large, right? I mean, what we used was a SVG sprite that was, if you did everything right, it was like 8.3 kilobytes. So I think this was, and that was before gzip, because you can gzip SVG. That's also cool. So I think this is okay because it served all the icons we were using in the entire conversion path. But if you have a large sprites, what you said makes lots of sense.
Okay. Cool. And what do you use for optimizing PNG?
OptiPNG. And I always advise people not to use PNG24 because there is no reason to do so. You can use bash scripts to convert PNG24 with full alpha transparency to PNG8 with full alpha transparency. That's still something lots and lots of people don't know. They still think that PNG8 only has this Boolean alpha sense, but that's not true. PNG8 can carry a full alpha channel, so you just need to use the right tools to do so.
Okay. And how about PNG Wolf?
APNG.
PNG Wolf. It's based on genetic optimizing of the bytes of the colors. It's actually 10% better than everything else that exists.
I have never heard about that. You have
Check
to
it
show
out.
me.
It's great. And how do you compare it to Smush It? Because it's
Smush It doesn't get much love these days.
Okay.
So I've been advising customers to go to Smush It for a couple of years, and I've been not doing that for more than a year now because I think Smush It is being slowly phased out. They always promised updates. They always promised, yeah, you will get access to the API, but they never do. And
Okay.
Yahoo is constantly shutting down services. So I think one of these days we will just hear the press announcement that Smush It is going down.
okay.
So
Sure. Thanks.
Anyone else?
I have a question about Adept because I'm also struggling with image optimization in WordPress. So I see on GitHub that Adept is a bash script. So how to connect it with PHP and hooks in WordPress?
Hook up to the upload process. That's the best advice I can give you. Find the WordPress hook that is available to hook into the process of creating the smaller images, and then take them, compress them with bash scripts or the command line tools available on the system, and then save them again. That's the best advice I can give you. Hook into the upload process. That's as close as you can get. If you have the problem that images are already saved on the server, you will always have the problem to find out, is the image already optimized or is it not? What you can do then is WordPress has, I think, 3 settings for where the media library things images are stored and where the what you see is what you get editor things images are stored. So you can use the options PHP of WordPress to find the setting in the GUI. then set the paths to different paths. For example, in a folder that's called uncompressed, where the media library items go to, and then you create the custom blocks, dir, whatever folder, where the items are actually saved, and you make sure that the watcher sees what you get editor uses this path, and then you write a script which iterates upon the upload folder and pushes the images to the other folder. But the only problem you would get then is if somebody uploads an image, he doesn't immediately see the thumbnail. So that's a problem. But also a problem that can be solved. But easier is to hook into the upload process itself.